Hello and welcome to the next video. So in our previous videos we have already set up the walking and running functionality. Here you guys can see our character properly planned towards each walk and run. So now let's set up the turn in place functionality. So for setting up turn in place, I'm gonna open up my animation blueprint. There we have the animation blueprint. So remember we have the track locomotion states functionality. So we'll need to perform the turn in place only when we are in idle state, right? So we have the track for that over here. I'm gonna so when we enter into run or walk state, we are updating our primary rotation, see, based upon our input vector. So if we have the input from 90 left, we are updating our primary rotation. So if we release the input, we need to check the current primary rotation value with our current rotation. So if that value is greater than at certain angle, let's say 45 or 30, which means we have that rotational difference between the current actor rotation and the target rotation. So if that difference is, let's say, greater than 30 or 45, we perform the turn in place animation. So here's the logic for that. So let's implement that. So here's our event graph. So when we are I'm gonna create a new function. I'm gonna call it on idle enter turn in place. So here we have the on idle enter turn in place. So when we are entering the idle state, right, when we enter on idle enter, we will execute this function. I'm gonna open it up and let's write the logic. So we have the primary target rotation. If we have any input, we'll transition towards walk or run, and based upon that we set the primary rotation. So we have our get primary rotation variable, and I'm gonna use property access, try get pawn owner and get vector rotation. I'm gonna use a delta between these two, between our current rotation and the target rotation. I'm gonna split the struct pin and promote this to a variable. I'm gonna call it TIP underscore rotational difference. TIP stands for turn in place and rotation difference is the variable name. So if the rotational difference, I'm gonna get the absolute value. Let's first print this out. So when we enter, it's the variable is 0. So there's one more condition. If the player start is, let's say, at 90 degree, there's this rotation. You can see when we are entered, this is the minus 90 rotation. So we also need to fix that. So in order to fix this really quick, I'm gonna use event initialization, blueprint initialization. I'm gonna set the primary rotation to our axis, try get pawn owner and get actor rotation. So when we are starting, our current primary rotation should be our current actor rotation. So now you can see blueprint initialization, primary rotation. This is not working. Let me find out why. Okay, so the thing is, event blueprint initialization animation is not setting up the primary rotation properly when we are starting the game. So instead of this function, I'm gonna use my event blueprint update animation. So I'm gonna add a sequence pin over here, and when we play the game, do once, we use do once, we need to set this variable just for one time, and we set this primary rotation to our current actor rotation. There we go. So now if I hit play, you can see the rotation difference is always 0 when we start. So this means no matter what the orientation you are, when you start the game, your start rotation will always be 0. Okay, so let's move on next. So I'm gonna open up the onIdle function. Just get me through my notes real quick. Okay, so here is our rotational difference. So I'm gonna get the absolute value. So if our absolute value is greater than our turn in place minimum angle, so I'm gonna promote a variable, I'm gonna call it turn in place minimum angle. So if our rotational difference value, let's set the minimum angle to 45. So if this is greater than 45-degree angle, only then we need to perform turn in place. Okay, so if it is greater than, instead of using branch, I'm gonna promote this to a variable. I'm gonna call it TIP for turn in place variable, and can turn in place, can perform turn in place. This will set our variable can we perform turn in place animation. Okay, and next thing is, so if we are not able to perform turn in place animation, so if turn in place is false, if this becomes false, we need to set a variable which will TIP underscore break turn in place. So you will see the use of this variable next when we set up the animation transitions. So we need this variable there. Okay, so let's add a branch over here. So if we can perform turn in place, first we need to get our target angle. So our target angle will be our turn in place rotation difference. Promote this to a variable. This will be our turn in place target angle. So this will be our target angle where we need to sync our character rotation, right? So I'm gonna add a branch over here again. So, and we need one more variable which is flip-flop, turn in place flip-flop. So you will also see the variable in action when we set up the transition logics. So the thing is, when we are, let's say, performing turn in place, and we just give another input to the player, and the character should break the current turn in place and perform next turn in place animation. So it's kind of flip flop between these two states. Either we need to perform turn place from A to B, B to A. So we'll use this variable to set up the animation logic so that animations can be planned properly. So here is our turn in place flip flop. So if this flip flop variable is true, I'm gonna set it to false. If this becomes false, I'm gonna set it to true. That's it. So this is our turn in place functionality. First we'll get the primary rotation, get the input vector based upon our input vector rotation and our current actor rotation. If that difference is greater than a certain angle, we'll set the can we perform turn in place true or not. So if we can perform turn in place, we are promoting the target angle using rotation difference and setting up the flip flop for turn in place. Okay, there we go. So now let's set up the animation graph for that. So let me open my notes real quick. So here's my animation base locomotion layer, idle state machine, and in idle we don't need state over here. I'm gonna cut it from here and add a new state machine. TIP state machine, turn in place state machine. So on entry we have the idle state. There we go. Paste the idle state over here. We have the idle, and from idle we can then go to add state, TIP turn in place underscore flip, duplicate TIP underscore flip flop kind of functionality. Okay, so we can transition from idle to turn in place based upon the logic, which is can we perform turn in place and turn in plus flip flop is true. If these conditions are met, then we can transition to our flip, and if not, we can transition. So if we can perform turn in place and our flip flop value is false, we transition towards the turn in place flop state, turn flip flop kind of functionality. So we also need the function transition between these two, and I'm gonna copy the conditions same from here, idle to flip, copy, and from here to here I'm gonna paste it over here, and from idle to flop I'm gonna transition from flip to over here. Alright, so we need the transition from flip flop to turn in place to back towards idle. So the first case will be if the automatic transition blend is true, set the transition origin point to 5, or the other condition will be if if we give another input while performing turn in place. If we give another input while performing turn in place, this means we should break our current turn in place. So if our break turn in place is true, similarly from here to back to idle, automatic will be as true. Or the second thing is, if our break turn in place will be true. That's it. So here are our transition logics from idle to turn in place. So if I open turn in place animation, turn in place state, we need a new state machine over here so that we know which animation to play. Either we need to play turn in place 90, 90 left, 180 right, 180 left, these states. So I'm gonna add a new state machine over here. I'm gonna call this turn state machine. Open it up, and we have the state, enter, and we can transition. We need TIP turn in place 90 left, turn in place 180 left, and turn in place 90 right, and one more, turn in place 180 right. So here we have 4 turn in place animations. So we'll set the transitions one by one. Like so. So from here, from enter to transition turn in place 180 left. So if our turn in place target angle is less than -120, then we can transition to 180 left, and we can transition to 90 left if our target angle is less than -30. Okay, so first we need to set the priority order to 180 left. So the priority order will be 1. If that becomes false, then we need to check the priority order 2, which is turn in place 90 left. Similarly for turn in place 90 right, if our target angle is greater than 30, if our target angle is greater than 30, then we can perform turn in place right and set the priority order to 2, because first we need to check either we can perform turn in place 180 right or not. So if target angle is greater than 120, then we can perform turn in place 180 right. Okay, these animations, there we go. So we have set the priority orders respectively and the transition logics. So next thing, we need to add the correct animations into the system. So for setting up the animations, as I have mentioned in my previous videos, we are using Echo's animation pack, so there is not any turn in place animations available in Echo pack. So I'm using the Lyra animations, unarmed animation for turn in place functionality. So here I have imported the animations from LiDAR starter pack to over here. So here we have the turn in place, left 90, right 90, 180, these animations. So we need some information, some animation curve, animation modifier logic into these animations. So for that, let me just go through my notes real quick. Okay, so if I open turn in place animation, here you can see we have proper root motion animations. The root phone has proper rotation values. Yes, you can see. So I'm gonna add a new animation modifier. We need to extract this rotation data from animation and map that into a curve, into a 0 to 1 form. So I'm going to use motion extract modifier. We need to get that bone data from root, and we need to get the rotation data in z-axis. We also need to normalize that data into 0 to 1 form, and also we need a custom curve name which will be rotation curve TIP, turn in place, rotation curve turn in place, and apply the modifier. Here you can see I have mapped the bone rotation into a 0 to 1 curve. See, and we also need one more curve which will be, I'm gonna create a new curve which will be our turn in place. I'm gonna set this curve to 1, which will represent, so if the turn in place curve value is greater than 0, which means we are performing turn in place animations. So we'll use this information into our event graph to update our character rotation. So we need these two modifiers for all 4 animations. So for that reason, for the remaining ones, I'm gonna select the remaining ones, right click and add modifier, motion extract modifier, rotation in z-axis, normalize, and custom curve name will be my rotation curve TIP, and apply. That's it. Here we have the rotation curve turn in place for each animation, and I'm gonna copy the turn in place curve and paste it for over here for all the animations respectively. So now these 4 animations turn in place, these 4 turn in place animation contains 2 curves, one turn in place and the other one is rotation curve. See, so now we need to put these animation into the respective states. So here we have turn in place 180 left, so I'm gonna open it up, and here we have the 180 left, turn left 180 left, put it over here. That's it. 90 left, get this, and turn left, put it over here. There we go. 90 right and right, there we go. 180 right and 180 right, there we go. So our turn in place state machine is ready now. So I'm gonna go back to the here. So here we have the turn in place flip functionality is ready. So we need the same functionality for the other state, which is flip flop state. So I'm gonna copy the same state machine and place it over here, paste it over here. That's it. All right, so now we have our turn in place states or animation graph is ready. So now let's test it out. Okay, so if I press A, our character perform turn in place. All right, so when I hit play and press the input, you can see my character not performing turn in place because we are in stopping state. So if I open the locomotion state machine, we first perform the stop state. So when we are performing stop state, so we need to transition towards idle. If we need one more condition, so if our, let me go through my notes real quick. If we can perform turn in place, is true, then we don't need to wait for stop state to end. We can just directly transition towards idle state and perform the required turn in place. So now if I play, see, our character perform the animation. There we go. Okay, so now our states are properly working fine. We now need to update our character rotation based upon our current turn in place animation.